Well, hello and welcome to second session of KCET Masterstroke for mathematics. Today we are doing inverse trigonometric functions. We have already done relation and functions, right? The chapter number 1, the session number 1. What you can do is let me know your feedback of the session in this particular session's comment section. I will go through it and see what we can do to improve the session furthermore, right? So again, as you know, chapter today discussion is going to be ITF. Okay, so what are we going to do today? We're going to learn the graphs. We're going to learn your domain and range. We'll quickly do that. There's not much concepts here, bacha. A simple chapter, not that difficult at all. All of you have agreed in the previous sessions comment section, okay, that yes sir, ITF is simpler relative to integration. We'll see integration also in the one shot, don't worry about that. So I hope you're ready for it. I hope you're up for it. So maintain the energy and learn this concept with me. Also, I have taken 5 questions over here to bridge the, to create a bridge between the concepts and the problems, right? So only 5 I've taken, bacha. We'll solve more questions from this chapter in our live sessions. So let's start the session now. So maintain the energy with you. If you have anything to ask, let me know in the comment section. Let's start the session right away, sir. What we have so far from here, first thing is the knowledge hub. Few things I wanted to explain it to you before I start with the actual session. What is that, sir? Inverse of a function. Have we learned about this, sir? Of course we have learned. Where, sir? In relation and function. We know that inverse of a function can exist only if the function is bijective in nature. Will you all not agree with me? Yes, you will all agree with me. Whenever the function is bijective in nature, then I can say function can be invertible. Okay. So what is the meaning of bijective, sir? It means 1, 1 and onto. Meaning of 1, 1 and onto, sir? Unique mapping. Unique mapping means each and every element of domain has a unique image in your codomain. Also onto means, bacha, none of the elements in codomain has to be left out. Means range and codomain has to be equal. When you get this type of function, then only you can invert or look for finding the inverse of the function. Okay, so that's what it is. So as the name suggests, ITF means inverse trigonometric functions. So we already have learned trigonometric functions, right, in PU1. So the inverse of those, for example, sin x is there. The inverse is what, sir? We have trigonometric function sin x. What is the inverse of that, bacha? Sin inverse of x. Sin inverse of x. Now we'll see the properties in detail, of course, but that's how we relate. So we'll see the graphs now. Don't worry. Domain and range of ITF. The range of ITF, as we have learnt. Where, sir? Inverse function, bacha. What if you remember? How do you find inverse of any function? You try to take image about this line. What is this line called as? Y equals to x line. It's incorrect actually. I'll draw it correct now because this has to pass from origin, right? Yes, sir. Chaliye, let's draw it. So this will be your line, right? So how do you find, bacha, inverse of any function? By taking the image of the function about this line y equal to x. Okay, so of course your y and x values are interchanged. So what you get in domain and range of ITF, so if let's say domain of this value is given here and range is given here, what happens here? This domain, bacha, will become range for inverse function, and this range, bacha, will become domain of inverse function. Please check, the range of trigonometric function becomes the domain. The range becomes the domain, okay, of ITF, and the restricted domain, very important word, sir, restricted domain, bacha. We'll talk about this in detail, don't worry, but right now let's just read this as it is. Restricted domain of the trigonometric function, okay, this part becomes the range of principal value branch of inverse trigonometric function. Is that clear? Sir, doesn't make sense. Don't worry, I'll explain it to you over here. Restricted domain of the trigonometric function. I have taken one slide just to explain you this part, okay? I love this section where I have to draw the graphs and explain it to you, and then it makes sense to all of my bachas. It makes me really happy. Let's check. What do we have over here? So let's draw the function. I'll take sin x, that makes sense. Okay, so let's draw the graph of y equal to sin x. Okay, the easiest of all, okay, function for y equals to sin x, sir. This much is okay, of course. How the graph looks like, bacha? Like this, right? Not perfect, but please accept it. Okay, something like this, where this highest value is going to be 1 and this value is going to be, bacha, -1. What are these values on x-axis? 0, pi, 2 pi, right? And over here I have minus pi. Over here I have, again, if you go like this, -2 pi and so on, okay? And this value is, bacha, pi by 2, and this value here is, sir, -pi by 2. Now what are we looking for? Are we looking for y equal to sin x? No, so we are looking for y equal to sin inverse of x. Okay, what did I say? Inverse can exist only if the function is 1 1 and onto. Is sin x bijective, sir? So basically, is it 1 1 and onto, bacha? Is it like this? No, sir, it's not 1 1. How come, bacha? How come it's not 1 1, sir? If I draw a line parallel to x-axis, any place I draw, I get infinite number of intersections. Sir, why infinite number of intersections, bacha? Because domain is actually all real. The domain for this function is all real, sir. Domain is all real numbers. So I get, bacha, infinite number of intersections. But we have learned this. For one function, there should be unique intersection for one value of x. Okay, it means, check this out, we are getting here, bacha, how many intersections? Infinite number of intersections, sir. Hence, not 1 1. Not 1 1. So if not 1 1, then how can we make invertible of this function, bacha? How can we make inverse of this function? For that, we have this concept called as restricted domain. So what we do, we cut the domain in some part and get that the value of the domain now, which is also called as restricted domain, and from there we try to get the inverse function. But sir, can you cut any way? Can we cut the domain in any way? No, bacha. You can cut the domain, you can restrict the domain only if the range does not change. So the range of the function y, okay, range should be changing, should be same. What's the range of this, bacha? We know this, -1 to 1. So restrict the domain, not a problem. We can cut the domain, provided that this remains as it is. This remains as it is. Then what happens, bacha? Then you get this particular function. Check this out, from here to here. Only this part. Only this part. Only this part. Please check. Now if you check this function, bacha, how many intersections you have if you draw a line parallel to x-axis? Only one, sir. If you check this only graph, this part, okay, what I'm gonna get? Please check. Please check. I'll erase this. I'll erase this. I'll erase this. Okay. I'll erase this also. Okay. Now check this out. What I have left? What I have left here is, if I draw a line parallel to x-axis, okay, parallel to x-axis, I'll have only one point of intersection, sir. Very beautifully. Check this out. For one line, I'll have one point of intersection. Same way, bacha, I'll have one point of intersection. Anywhere you draw, you'll have only one point of intersection. Now, sir, with this domain, the function this has become 1 1 and it's onto also. It's onto also. Range and codomain is same, sir. It means now it is bijective, so invertible. Now it is invertible, sir. Got it? So what we do is, we restrict the domain with the understanding that range remains unchanged. So what is the domain now for this function? The domain becomes, bacha, -π/2 closed to π/2. And the range, sir, range remains unchanged, -1 to 1. This part is clear. Is this part clear? Of course. Okay. Now we'll look into how to find inverse, how to find the graph. That is all right. But this slide was only to inform you how do we get restricted domain and why do we need that. That also is very important. Why do we need that? To make that inverse happen, we have to make it bijective. Hence, we are doing the restriction on the domain. Is that clear? Okay. So please have a look. Only condition is that this is very, very important, bacha. Range should not change, sir. Okay. Achha, one more thing. Can we not draw this function more than one way? Of course we can, sir. Let's check, bacha. I can draw this function more than one way, no? Like this also I can draw. I'll have over here, no, someplace. At π/2 it is going to be 1. So I'll have again at 3π/2. The function will be like this. Here also I'll have a function like this. Okay. So these branches can be more than once. Okay. But this particular branch, bacha, is called as principal value branch. I can have the function like this even after π/2 to 3π/2. Okay. π/2 to 3π/2. Okay. Not sorry. Yeah, 3π/2 to like that I can draw. But important thing is what will happen, bacha? It should be looking for this value, then it'll call as principal value branch. Principal value branch. Is that clear? That will come with respect to your inverse function, but still wanted to tell you that this is called as principal value branch. That's what was mentioned over here. I'll show you right away. Take this out. principal value branch of inverse trigonometric function. Principal value branch of inverse trigonometric function, not with trigonometric function, with the inverse trigonometric function we get principal value branch. Okay, this is clear. This graph is clear. You have a doubt, you let me know in the comment section. Okay, next, sir, again we are going to summarize something. So again we are back here in knowledge hub. What is there, sir? Whenever no branch of an inverse trigonometric function is given, we mean, that's what, if it is not specified, bacha, let's say there's just a function is given and they're not given any specification, not defining it which interval, then we'll assume what, bacha, we're talking about principal value branch of the function. Okay, that is understood condition. Okay, for example, when pi value is not given, what you should take? 22 by 7, not 3.14. We'll take 22 by 7. Same way, if nothing is specified means we'll take principal value branch. Okay, what is that? Minus pi by 2, pi by 2, and this is different for other functions. We'll show you. The value of the inverse trigonometric functions, which lies in the range of principal value branch, is called as this. Principal value of inverse trigonometric function. What is that going to be? Tell me. The angles minus pi by 2 to pi by 2. Yes. Now, bacha, we'll talk about the graphs. I'll show you one graph. Okay. I'll show you one graph. Okay. And that's all. I will not draw all the graphs for you. I have already written the graphs for you. You can see the graphs I've already taken here. I'll explain you the other graphs, but I will help you draw one of the graph. Okay, just to help you what actually it means. It's not required. You actually don't need to draw the graphs. Okay, rough is more than enough, but I still want to do it to make your understanding better. Chaliye. So let's take the first graph, sir. Sin x, y equal to sin x I'll take. Y equal to sin x I will take, bacha. So do I draw the full thing, sir? No, only principal is enough. So we'll draw like this. Check it out. That is more than enough, right? This value is very important to write. So mention it over here. This is going to be, sir, minus pi by 2, and this is going to be, sir, plus pi by 2, and the value is over here coming as what, sir? Minus 1, over here coming as plus 1. Plus 1 and minus 1. Is that clear? Plus 1 and minus 1. Chali. Now, as I said, whenever you're taking an inverse picture, what you do? You take mirror image about this line. Which line, sir? Y equal to x line. So draw this line, bacha. That's the line. Okay. Chaliye. Can I draw this better? Let's just draw this line. Sin x graph better. Okay. I can do this. Okay. Something like this. Okay. 1 second. You already know my graphing skills are not very good, but I'll try to make sense. Okay, this is the graph will look like. What graph is this, bacha? Y equals to sin x. What graph is this, sir? Y equals to x. Okay, now take the mirror image about the line. Okay, what are you gonna get? What are you gonna get, sir? The image of this part about this line, the positive part from here to here, about this line will be something like this. Okay, will be something like this. Okay, think about it. And bacha, this will become over here. Okay, of course it will not pass the 1 point. I just want to make sense to you. Okay, this part and this part will be symmetric, and this will be symmetric. So the graph of y equal to sin x will, no, not sin x, y equal to sin inverse of x, no, will become this. Please check. It will become, bacha, this value. It will become this. What are the conditions now? Remember, x and y are interchanged, sir. So the x-axis and y-axis value will be interchanged, sir. Here x was angle. It will become the value now. So x will go from where to where, sir? It will go from minus 1 to 1. And y will go from where to where, bacha? It will go from minus pi by 2 to pi by 2. Is that clear? Please check. Is it clear? Okay. So this is the graph of y equal to sin inverse x. Y equal to sin inverse x. Is that clear? Okay, sir. Now let's learn some nature also. What type of graph is this, bacha? What type of graph is this? What type of function is this? Y equal to sin inverse of x. What type of function is this, bacha? So first thing is an increasing function. Increasing function, sir. We're talking about nature of the graph. It's increasing function. How come, sir? If you take a value x1 more than x2, let's say I take this value over here. Two values, x1, x2. What happens here? F of x2 will be always more than f of x1. Okay, increasing graph. As you grow from here to here in x-axis, the y value is increasing, sir. That's why increasing function. Second, bacha, is it a periodic function? Not a periodic. not periodic. Okay, what else? Can we see the maximum minimum value? The minimum value bacha is minus pi by 2, maximum is pi by 2. The minimum value is minus pi by 2 and max value is pi by 2. Okay, what about even and odd? So symmetric about origin bacha. Symmetric about origin means y equals to minus x. That part we can do, no? Symmetric about origin bacha, what will happen? Odd, sir. Odd function. It's an odd function. So this is all the nature about this graph y equal to sine inverse of x, increasing, not periodic. We have this minimum value is this, maximum value is this, and it's an odd function. Please check. Okay, chaliye. Great. So once that is clear, I think now I'll show you the other graphs and we will just learn from the graphs itself directly. Okay, so this graph is clear, right? This part is clear. Yes sir, this part is clear. Minus 1 to 1 is the domain, range is minus pi by 2 to pi by 2. I think this is, I've written over here. No, I've not written. So let's write the domain first. Domain is what bacha? Minus 1 to 1. Minus 1 to 1 closed. Range bacha is minus pi by 2 to pi by 2. Again closed. Okay. Same thing written over here. What about cos, sir? It becomes 0 to pi. How come? Again, you can draw the graph for cos x and take the image about the line y equal to x. Okay. So domain is minus 1 to 1. Range is 0 to pi. The graph looks like this. For tan inverse, bacha, what will happen? It will be again an increasing function. This is a decreasing function, right? This is a decreasing function. This is a decreasing function. This is an increasing function. Okay. This is a increasing function again. Okay. This is again odd. This is not neither odd nor even, right? Because not symmetric about, if it was symmetric about y-axis, no, I can say even function, but not symmetric. Is symmetric? Symmetric means this, right? Not symmetric, okay? It's not symmetric, bacha. So it will neither be odd nor be even. Whereas in the case of tan, bacha, what will have? It will be again increasing and odd. Increasing function and odd, bacha. This is odd again. Not visible, right? Is it visible? No. So just check. This is odd, bacha. Tan inverse is odd. I already have taught you this, but still I'm here, so I'm explaining this thing to you again. What is this? Very, very important. What is this, sir? Cosec x. What is the domain, bacha? Minus infinity to minus 1, 1 to infinity, and range, bacha, minus pi by 2 to pi by 2, except for 0. Over here again. So don't worry, I have listed this to you in the table. I'll explain it to you. The graph of sec inverse, the graph of cot inverse of x. Okay, they are rarely used, okay, in your lessons, but these three are very, very important for you. This is used sometimes for your JEE and all, but usually in KCET they have not asked questions on this, but if they are asking, I have given you the graphs here anyway. Okay, so how can you get these graphs? Of course, you'll have in your textbooks, but if you want the sessions PDF, you have to join the WhatsApp channel. If you already joined, then very good. It will be delivered to you in the WhatsApp channel. Download it from there. If you have not joined yet, join right now. Again, don't worry about any fee or something. It's available completely for free. Okay, chaliye. So, bacha, graph of ITF is clear. Now, domain and range. As I said, I have listed it out for you in a table. Don't worry. So, for cosec x, remember this. Minus 1 and 1 is in the solution. This is open here, bacha. What I'm doing over here, very important. I want to explain you for cosec and sec part. Check this out very carefully. Minus 1 to 1. Minus 1 to 1 is part of the solution. How come, sir? Because we're talking about what, bacha? From the all real, we are removing from minus 1 to 1. But is minus 1 and 1 removed? Is minus 1 and 1 removed? So not removed. Not removed, bacha. How come, bacha? There is no equality over here. You have to write square brackets for that, right? That's why it is part of the answer. So minus 1 and 1 is part of the domain of your cosec x. Same goes with sec x also. Same domain. Domain remains same for sine and cos also. It's cos here. Sine and cos also domain is same. Sec and cos x domain is also same. For also tan also same, bacha. Tan inverse, cot inverse, domain is same. Check the range. For sine and cos, bacha. For sine it is minus pi by 2 to pi by 2. For tan it is same, but with the open bracket. With the open bracket, bacha, tan is same. Alright. Why open, bacha? Why open, sir? Graph, if you remember, is tending to infinity, sir. Is tending to infinity. Can it ever become infinity? No. That's why open. It can never become infinity. Can it become infinity, sir? Of course not. Check this out. I don't think this is visible. So this value is, sir, minus pi by 2, okay? And this value is, sir, pi by 2. Okay, so this can never become negative of pi by 2. Why bacha? Because never reaching the infinity. This is bacha negative infinity, no? And this is bacha plus infinity, right? So never reaching plus infinity also. That's why never pi by 2. Open bracket. That's why open bracket here. Check this out. Open bracket here, not closed, open bracket, okay? For tan. For cos inverse 0 to pi, okay? And for sec bacha, what is there? Pi by 2 is not there. Why pi by 2 is not there, sir? Bacha, what happens? Sec, sir, at pi by 2 will become 0, right? Oh no, it will become infinity, right? That's why. It will become infinity, okay? Same, sir, cot inverse x has range of 0 to pi. And tan inverse, I will explain to you, cosec inverse has range of minus pi by 2 to pi by 2. 0 is removed because it will become infinity, no? That's why. Chaliye. So this is your table. You have to remember this, very relevant to you. Now we'll quickly look at some questions also. Okay, the value of cos of tan inverse 3 by 4. Difficult question? Of course not, sir. Not difficult at all. Let's check. Tan inverse of 3 by 4. Let's do one thing. Make an assumption. Tan inverse 3 by 4 becomes equals to, let's say x. Let's say x. Okay. What we can do about this? It'll give me bacha, this is my assumption, okay? From here I get 3 by 4 equals to tan x, right? Moving the tan on that side. So can you draw a right angle triangle for this condition? Yes, sir. If this is my angle, let's say x, this is the perpendicular or opposite by adjacent. So this is 4, 3 by 4. 3, 4, 5 is a Pythagorean triplet. So this will become 5, sir. 3, 4, 5 is a Pythagorean triplet. So 3, 4, 5. Right now, cos x. So sir, cos x will be bacha, nothing but base by hypotenuse. So base is 4, sir, 4 by 5. This also is clear. Clear, sir. Okay. Clear. Now, write this. What is they have given? Cos of tan inverse of 3 by 4. What is this value, sir? What is this value, bacha? Check this out. X. So right here, this as x. So cos this becomes x, right? What is that value given as? 4 by 5. 4 by 5 is my result. So hence option is A, right? Option A is correct. Please check. Simple question. Very simple, right? Next, the domain of fx given like this. I have taught you this very recently. Whenever the function is given like this, fx plus gx like that, what do you do? Look for intersection of the domain. So find the individual domain of all the function and look for intersection, right? So how can you find that? Check it out. I have sine inverse of x. What's the domain, bacha? Domain, sir. Domain, sir. Not range. Domain minus pi 2, minus 1 to 1. Okay. Tan inverse of x. Tan inverse of x. Domain, sir. All real. Not the range. Range is the angle. Okay. In the trigonometric function, it was opposite. Remember, in the inverse trigonometric function, what happens is result is always an angle. Okay. That's why domain is always a real number. What about this, sir? Sec inverse of x. Sec inverse of x, but what happens here? All real minus open bracket minus 1 to 1. Will it be closed bracket, sir? No, I just explained to you. Minus 1 and 1 is part of the answer. Okay. So I'll show you all of this result on the number line. Okay. So check this out. This is the curve. Negative infinity to positive infinity. Okay. The values are here. Minus 1 to 1. The critical values. Minus 1 to 1. Okay. Now I'm going to represent, first thing is sine inverse of x. From where to where, bacha? Including these two values. Okay. And this. Is that clear? This is my sine inverse of x. What is that, bacha? Sine inverse of x. Okay. Next, tan inverse of x. All real. Tan inverse of x. So all real. This is open, of course, to all real. Open, of course. This is the tan inverse of x. 1 second. I can do better. Tan inverse of x. This all real value is tan inverse of x. Intersection of those two. Intersection of those two. What is that, bacha? Is going to be simply minus 1 to 1. Right? All real with this. Intersections are minus 1 to 1 only. So far my answer is this. Minus 1 to 1 closed. Okay. Minus 1 to 1 closed. Clear now? The last part. All real except for this. So the last part, what is the answer, bacha? For the last part, answer is coming like this. I'll show you below. I'll show you below. So the last part, the answer is, of course, open here. All included. Open at minus 1. Okay, no, close it, minus 1, not open, close, right? Close, sir. How come close, bacha? Minus 1 is part of the answer. Then there's no solution over here. Again, close over here, and then all of this open at infinity. Okay, so now if you combine this with this is the result, right? From here where I'm getting minus 1 to 1 with this, bacha, what I'm getting only two answers. One is this minus 1, other is this plus 1. So I'm getting only one answer. This x equals to minus 1 is the part of the domain, and this, bacha, x equals to 1 is the part of the domain. So I have only two values. Combination of these two, this is the answer. Combination of this with this part, what is the answer, bacha? Only the extreme ends, minus 1 to 1. So my answer is going to be minus 1 and 1, not 2 individual values. So curly bracket, option number C. Option number C is correct. Getting my point, right? We are not having value from minus 1 to 1. Only minus 1 and 1. Why not, sir? Because in second verse, this part is not there only. This part is not there only. Getting it or not? Let me know your doubt in the comment section if you're having. Okay, so question number 2 is done. Let's check. Moving on to the properties of ITF. The last part, the properties. As I said, chapter is very simple. Okay, yes, you need to solve questions on it. What you can do is, I'm going to solve some more questions on this. I've taken 3 more questions. I'll solve that in the session itself, and you can solve more questions from my previous sessions in the KCET series. Or what you can do is you can use any like your what you call question bank from any publication and solve the questions from there. Or I'm going to solve some more questions in the live session. Okay, so but you have to solve some more questions. Chaliye, properties of ITF. Sine inverse of sine x is simply x when x belongs to this. What is that, sir? Minus pi by 2 to pi by 2. Okay, this is the domain of sine x. Same, bacha, here cos x domain, sir, 0 to pi. So it'll be x. So in the standard domain of the sine, cos, tan, cot, sec, cosec. Okay, this is the domain of this, right? Sine, cos, tan, cot, sec, cosec. I get this value as x. Okay, what if I am getting something like this? Sine inverse of minus x. This is very simple, right? Minus sine inverse of x. How come, sir? Odd function. Same, bacha. Tan inverse of minus x. What are we going to do? Minus tan inverse of x. We have actually only 3 relevant to us. That is more than enough. And the last one, use most of the time. This, bacha, will be coming as pi minus cos inverse of x. Okay. So we don't need to do the derivation of this part. There's a derivation of this. Yes, there's a derivation for all these formulas, but we don't need to do that. If you remember this formula, this 3, that is more than enough. Accept my statement. We don't need to do the derivation. There is a derivation, but bacha, we have some crunch of time. We don't need to do all of that. Simply, if you learn these formulas, that will be more than enough. These are again properties of ITF, sir. When we have dealing with negative angles. What is the meaning of negative angle, sir? Angle is over here. This is the meaning of minus x. That's the meaning of minus x. All of you agree? Yes, sir. Please check. Okay, now what I can do is I'll move on to your question number 3. Let's solve this question as well. What I'm getting here, the principal value of sine inverse of cos times of sine inverse of root 3 by 2. Actually, one more thing. The first 2 chapters were very simpler in your PU2. That's why we are doing little less right now. But once we go to the high weightage chapters, again, this is also high weightage, only not very less weightage. ITF has little less weightage, but relation function has good weightage, bacha. It's not very, like you can just ignore the chapter. ITF has less weightage, but as I said, important for, calculus. That's why I'm, revising this part again. I wanted to do calculus first, but I just thought, let's do this first. Because if you have forgotten some things, so important to revise it right away, then we move on to the calculus part. So next sessions onwards, you'll have continuity and differentiability like that. You'll have the entire calculus first covered. So I'll do the entire calculus first, then I'll move on to some of the topics of PU2. That is clear, right? So that's why it'll be a little small session right now, but once we go into that section, we'll have again lengthier. So be prepared for that. Don't get in your mind that some maths will be a little smaller. No, it will all be like that. You'll have a lengthier session. I'm sorry for that, but it will be like that, bacha. When you go to integration, when you go to matrices and determinant, when you go to vectors and 3D, the session will be longer, and again differentiation also, session will be longer only. Okay, so be prepared for that. Right now, have fun until when you can. Okay, so what I'm gonna give you, this question number 3. I think you can solve it. I can't give you as homework. I'm going to solve it over here right now. But do one thing. If you want to try from your side, pause the video and try right now. And then come back and check the solutions with me. That works? Okay, so So principal value of sine inverse of cos, sine inverse of minus root 3 by 2. We're going to apply the concept that we learned right now, the properties, okay? Check this out. So we'll start from where, bacha? From here only. So keep this as it is, sine inverse as it is, cos also as it is, and we'll operate this part first. Sine inverse of negative value will become, bacha, minus sine inverse of root 3 by 2. Achha, one more thing, we have to remember the principal values, okay? Some special angles are there, no? That you have to remember for trigonometric functions. We learned in PU1, right? Sine 30, sine 45, like that. Remember all the angles, okay? So what we have over here, check this out. This will remain as it is, sine inverse of cos. Bacha, this will become minus sine inverse of root 3 by 2 is so simply pi by 3. Simply pi by 3, correct? Now cos, if it was cos inverse, be careful, it is not cos inverse, it is simply cos, sir. Cos of minus theta, bacha. How much is that going to be? Simply cos theta. How come, sir? How come, sir? How come, sir? Even function, no, symmetric about y-axis. Cos, draw it. Symmetric about y-axis, bacha, even function. Okay, chaliye. What do we have over here? Okay, I'm not talking about cos inverse. Cos I'm talking about, okay? Anyway, second, we have in the fourth quadrant, cos is positive. Fourth quadrant, so the angle is fourth quadrant, negative of theta. Cos is positive, bacha. Okay, so what will this be? Sine inverse of cos pi by 3. Hence, sine inverse of cos pi by 3 is how much, bacha? Is going to be 1 by 2. Sine inverse of that, bacha, will be simply pi by 3, right? No, pi by 6, right? Pi by 6, not 3, sir. Excuse me. Pi by 6. Pi by 6. Answer will be option number B. Option number B is correct. Pi by 6. Okay. What you can do, actually, you know, you can write this. There's another way to solve this question from here. You can write like this also. Sine inverse of cos of. Okay. Write like this. 1 second. 1 second, sir. Just a second. Sine pi by 2 minus pi by 3. Okay, that is your answer. This will become, bacha, simply pi by 6 only. Sine inverse of sine, bacha, will be gone. You'll have only pi by 6 left over here. Please check. Please check. Okay, same thing. Same result over here. You can write from here also. Same way, or you can solve it like this. Same way. Please check. Okay, question number 3 is done. Moving on to question number 4 now. Let's solve this question. Question number 4, sir. Let's have it. Find the domain and range of fx equals tan inverse of log with the base 4 by 5. Okay, few things to remember over here. Log with the base 4 by 5, sir. What it means? It means, bacha, log will have a decreasing nature. Right? Log, when the base is what, less than 1 and more than 0, what happens? It becomes like this. If it is more than 1, bacha, the graph will be like this, right? But we have less than 1. No, 4 by 5 is less than 1. Hence, the decreasing log. This part is clear. Okay, now we are looking for domain and range, right? So domain can be defined only using this part. Okay, let's do that. So what we have over here is 5x square minus 8x plus 4. This has to be greater than 0, right? Log cannot operate on negative value. Check this out. Never negative, only positive, not even 0. Always greater than 0. Not equality, always greater than 0. Non-negative is not good enough. Only positive has to be there. Okay, 0 cannot also be the part of the domain. Okay, solve this over here, bacha. We'll try to make whole square over here. Why, sir? Perfect square is always positive. No, that's why. Okay, let's do one thing. Take 5 common over here. What I get like this is x square minus 8 by 5x. Okay, and keep 4 outside. Keep 4 outside. Okay. So what I can get from here is x square is already there, minus 2 times of x, that is 2a, a square minus 2a. What should be the b, bacha? It should be just simply 4 by 5, no? Check this out. 4 into 2 into x, 8x by 5. So basically my b value is 4 by 5. We need the whole square of that. So 4 by 5 the whole square. Extra I'm adding something. Remove that. Minus 4 by 5 the whole square. Close the bracket. Plus 4 is outside the bracket. So add plus 4 greater than 0. Plus 4 is outside, right? This is outside over here. Can I simplify this? Close it out. I get here x minus 4 by 5 the whole square. This thing the first three terms, the whole square, minus 16 by 25, close the bracket, plus 4. Please check, plus 4 greater than 0. Plus 4 greater than 0. This is extra bracket I have taken over here. I'll remove it. Alright, sir. What else I have? Check this out. What else I have? So I can solve from here. Take this part outside. It will become 5 times of x minus 4 by 5, the whole square, minus 16 into 5 by 25 plus 4 greater than 0. Check it out. 5 is a, so 5 times of x minus 4 by 5, the whole square. What I'm getting here, bacha? LCM, if you take, put a plus sign over here, 5 is the LCM. I get minus 16 plus 20, right? Why plus, bacha? I'm taking this minus 16 with this term only. Negative I'm taking with 16 only. That's why I've taken plus sign over there. I get 5 times of x minus 4 by 5, the whole square. This will become, sir, 4 by 5 greater than 0. So it's true. Correct? No, this is a positive number. And this is a positive number. So positive or 0 it can become. If you take excess 4 by 5, it will become 0, right? If you take excess 4 by 5, it will become 0. And this is positive, sir. Positive or 0 and positive. Add them, always will be greater than 0. Correct, na? If you add a positive number to a, even smallest possible case, 0, sir. This can be smallest value of this, bacha. Smallest value of this part, 0. Add a positive number to that. Greater than 0, no? Agreed? This is 0.8, right? This is a 0. Let's say I take this as 0, smaller value. Okay? It will become still be greater than 0. Hence, sir, this is always positive. So for what value of x, this condition is true? For x belonging to all real numbers, what I get, bacha? This condition is true. And this has to be true. That's what we've taken. It means domain is infinity to infinity, negative to positive. So answer is simply coming as option number A. But we'll solve it anyway for the range part also. But hence you can get from here directly is that FD is the all R. What this means, sir? All are only. No, what it means is negative infinity to plus infinity both open. Right, that's your answer for domain. Clear? Let's look at the range now. What is the function? Write your function. Y equals to tan inverse, right? Tan inverse of log. Okay, I don't have y over here. I have, sir, simply fx, right? I think they have mentioned here fx. Yeah. So I'll take here fx. Okay. What else I have, bacha? Log 4 by 5, 5 square minus 8x plus 4. 4 by 5, 5x square minus 8x plus 4. Am I right? Please just cross check once. Okay. This is correct. Alright, sir. So for range, bacha, we already have one condition. That this value of, if I take this to be, if I take this part, 1 second. If I take this part to be, bacha, let's say polynomial px. Okay, if I take the polynomial to be px. So, sir, this px will have a smallest value equal to what, sir? Check this out. This thing can become 0, right? Smallest value of this is 0. So this is the smallest value, bacha, 4 by 5. This is what, sir? This is the entire thing, no, px only. I have taken what, bacha? The same value is, written in different format over here. Is this and this different? No, same thing, sir. This and this is same thing. So the smallest value possible for this given polynomial px will be what, sir? 4 by 5 only, no? Because when this becomes equal to 0, smallest value of this part is 0, sir. Smallest value of this part is 0, sir. So hence the polynomial will have a smallest value of 4 by 5. So write this as 4 by 5, smallest value, and largest, bacha, infinity. How come, sir, infinity? It'll keep going, till where, bacha? Till, sir, infinity only, no? This will keep increasing, right? If any value you take for x, it'll keep increasing, sir, to infinity. Always positive, right? Okay. Now I want to apply log on that. So apply, sir, log with the base, log 4 by 5 with the base. What I have? 4 by 5. Okay. Log of p of x with the base 4 by 5. Okay. And log of infinity with the base 4 by 5. Now check the beauty of this part. From here, inequality will reverse, sir. Inequality will reverse. How come, bacha? Log with the base 4 by 5 is a decreasing function. Means sir, if I take x1 is greater than equal to x2, what will happen to f of x1? Will be less than equal to f of x2 bacha. Yes or no? It's a decreasing function, right? It's a decreasing function. If you increase the value of x, what will happen to y? Coming down, sir. So decreasing function. That's why the inequality is reversing, sir. Because log is decreasing in nature. 1 second, I made a mistake over here. What's the mistake, sir? I've taken equality. That is not there. That is not there. It's given here. Inequality is there. No, only inequality. There's no equality over here. So this inequality is reversed because of the decreasing function nature of log with the base 4 by 5. Not always. Only because of the base 4 by 5 is decreasing in nature. That's why what happens, bacha? Inequality is reversed. What is it going to be, sir? 1, no? Log 4 by 5 to log 4 by 5 is 1, sir. What I get here? Log px with the base 4 by 5. Okay? And this becomes, bacha, greater than log of infinity, bacha. Take x to infinity. Take x to infinity over here. What happens to y, sir? What happens to y, bacha? Negative infinity, sir. It will become negative infinity, sir. Log at infinity, bacha. Check this over here. Log at infinity is nothing but going to negative value of infinity, right? For y. That's why negative infinity. Okay. What we have to apply now? We're looking for tan inverse now. Now apply tan inverse. Increasing function. No need to change our inequality. So apply here. Tan inverse of 1. Okay. Inequality will remain same. Increasing function tan inverse. What happens here? Tan inverse. What is bacha? Log of px with the base 4 by 5. And then tan inverse of negative infinity. Right? Check this out. How much is that going to be? Pi by 4. Pi by 4. What about this, bacha? What is this part? So simply fx. Simply fx. So right here. Simply fx. What about this, bacha? Minus pi by 2. Open. Why not close? Why not close, bacha? Because, sir, there's a open over here. Open inequality. This is an inequality, right? So open inequality. That's why. Check this out. Not visible. I'll write it again with a different color. Okay, 1 second. This is the inequality over here, right? Check this out. Okay, so I get this value of fx from where to where? From minus pi by 2 to pi by 4. This is closed and this is open. This is open. This is open. This is closed. If you want, I can show you over here as well. The graph I have mentioned, right? Check here. The graph for tan. Here, bacha, what is the value? Minus pi by 2. Is it open or closed? Sir, open, sir. Open, sir. Open value. Okay. Hence, I have this value over here as, check this out. Question number 4, right? Minus pi by 2 to pi by 4. I think same thing is written over here. Correct. Is it a good question, sir? Yes, it is a good question. Why I've taken it? Because it involves a lot of concepts in it. That's why I've taken this question over here. Please check. I hope this is clear. Okay. Let's move on to question number 5 now. This is all clear. Let me know if you have a doubt in this question number 4 in the comment section. Okay. Value of cot of this operation, bacha, here. First we have summation. Then we have cot inverse. Then we have summation. Then we have cot. Very good question. Okay. So cot, summation, cot inverse, then again summation. So we'll start from where? Again from the inside. Okay, from here. Let's begin. Let's begin. Keep this part as it is. Cot part as it is. Okay. This summation as it is. Summation of n1 to 23. Okay. This cot inverse as it is. Now check this out. 1 plus is there. I'm going to take this 2 outside. Constant, no? 2 outside. Summation of k equals to 1 to n. I have k. First bracket closed. And then, bacha, we have second bracket also closed. Okay. Now let's have a look. Okay, I can change the ink color. 1 second. Okay. Have a look now. What I'm getting for this part. Cot I'll keep as it is. Cot I'll keep as it is. This summation will be again as it is. N equals to 1 to 23. What about this, bacha? It will become cot inverse. Again, this bracket as it is. Check this out. I get 1 plus 2 times of n into n plus 1 by 2, sir. How come, bacha? How come is this true, sir? Please check. Because this is the sum of first n natural number. Formula is this. From where we get summation of AP. Check this out. Okay. So from here I get 2 and 2 is cancelled. Okay, what else I have? Next step number 1, step number 2, step number 3. Very good question. Okay, just be a little patient. Okay, cot inverse, what I'm getting now, 1 plus I have, right? I have 1 plus n times of n plus 1, same thing is there. Okay, close the bracket. I can write this cot in terms of tan inverse now. Let's do one thing, write this cot in terms of tan inverse now. So it'll become, check this out, tan inverse, what bacha, 1 upon 1 plus n times of n plus 1. Okay, this is a bracket, that is more than enough. Okay, now what I have, check this part out. Cot will be outside as it is, this bracket as it is. Okay, summation over here, n equals to 1 to 23. Okay, and right here tan inverse as it is. And now over here, please check what I'm gonna do. I'm gonna write this as n plus 1 minus n plus 1 minus n, sir, divided by 1 plus n plus 1 into n, sir. Close the bracket, close the bracket. Now do one thing, group them, group the numerator. Can I do this? No, of course I can do this. How come, sir? Please check. I can do this or not? I can, but why? Why can I do this? Tell me. Because sir, n plus 1 minus n, sir, and n gets cancelled. Okay, so no change actually, so remains as it is as 1. Okay, now we have the formula tan inverse of A minus tan inverse of B. What is that going to be? Tan inverse of A minus tan inverse of B upon 1 plus tan inverse of A into tan inverse of B. This formula I'm talking about. Tan inverse of A minus B is given by tan inverse of A minus tan inverse of B divided by 1 plus tan inverse of A into tan inverse of B, sir. Where we learnt it? Okay, check this out. This comes from where, bacha? Trigonometric functions. Okay, now one more thing. Have a look. This RHS is given here. This is the RHS given over here. So I can write this simply in terms of LHS. It will become what, bacha? Tan inverse of n plus 1 minus tan inverse of n. So this whole thing will become, have a look. This whole thing will become, cot will come first, then this bracket, summation is there, n equals to 1 to 23, and then I get this as another bracket, tan inverse of n plus 1 minus tan inverse of n. Please check. That's the formula. Have a lock. Okay, this is the product. Okay, this is the product, bacha. 1 plus tan inverse of A into tan inverse of B. Okay, next what, sir? I substitute the value of n from 1 to 23. Cot will be outside as it is, not a problem. 1 second. Cot will be outside as it is, not a problem. Yes, so I can write like this. Check this out. What I'm gonna get, summation, if I put let's say only lower limits, okay. If I put only lower limit, bacha, for this part, sir, for this value I'm gonna put 1 to 23, and for this value I'm gonna put separately. Okay, what I'm gonna get for this part, I'm gonna get tan inverse of, put n as 1, it'll become tan inverse of 2, sir. Okay, put n as 2, so tan inverse of 3, sir, and dot 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 till you put 23, it'll become, sir, tan inverse of 24. Check this out. Tan inverse of 1, if you put n equals to 1, it'll become 2, right? You put n equals to 2, it'll become 2 plus 1, so 3. You put n equals to 23, it'll become 24. Clear? This is part clear. Okay, next part, sir, negative sign part. So I'll take a minus sign, okay, and then write a bracket over here, and check this out. What I'm gonna get, put n equals to 1, I'll get, sir, tan inverse of 1. Okay, then I'll have a plus sign. Okay, it'll become, bacha, when I put n as 2, I'll get it as tan inverse of 2. Next, bacha, so I'll keep continuing till, okay, I'll write one more term, tan inverse of 3. If you put n as 3, last will be what, bacha? Dot 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 tan inverse of 23. Okay, so this bracket is closed, and there's one more bracket. Have a look. So what we're getting over here is very nice. This positive with this negative. So where negative, bacha? This is a minus sign. Okay, this positive with this negative. Same again, this will be also cancelled because there will be tan of 23 before this 24. right? This is all negative, no? There's a minus sign over here, all negative, okay? So what I'm getting from here, I'm getting this as cot tan inverse of 24 minus tan inverse of, what is left now? Only 1. This is left, bacha. Tan inverse of 1. Can you solve it? Of course. Cot will become, check this out, tan inverse of 24 minus 1 upon 1 plus, 1 second, 1 plus 24. 1 plus 24 into 1, bacha. Okay, what I'm getting now? I get this as cot of tan inverse of 23 by 25. I can again write in terms of cot inverse now. It will become, what is this going to be? Cot inverse of 25 by 23. Okay. So this will become, bacha, simply 25 by 23 is the answer. 25 by 23 is the answer, sir. Please check. Option is B. Option is B. Please have a look. Okay, this part is clear, right? How did I cancel? N plus 1 minus n. Okay, so n plus 1 for 1, if you put 23, it will become 2 to 24. If you put 1, it will become 1 to 23. So you have 1 extra 24 and you have 1 extra tan inverse of 1. Okay, that's why that is left over here as tan inverse of 24 minus tan inverse of 1. Please check. Please have a look. This part is clear. Question number 5 is clear, sir. Okay, this bacha concludes our session today. Okay, I hope you had fun. I hope you enjoyed. You let me know your feedback in the comment section. Again, I'll be starting with your coming calculus. So let me know how you feel about that. Anything you want me to add in the sessions, I'll do that. Don't worry about the questions. I'll give you more questions in the live sessions. Okay. So with this, I'm going to end the session today and just keep working out. Keep working very, very hard. Okay. You have very less time now. So I understand if there is a frustration. Talk to us, whatever you can, tell us. We'll try to come back to you. We'll try to motivate you. We'll try to talk to you in the best way possible. Again, we can do that in live sessions as well. So with this, I'm going to end the session today. Take care of yourself. Bye-bye.